We're going to continue writing linear equations. What we're going to be doing today is we're going to be turning point slope into slope intercept form when we're given just 2 points. And then we're going to be looking at parallel and perpendicular slopes. So starting us off, we have 2 points. What we're going to do is we're going to find the slope of those points, and we're going to use the slope formula. So just in case you forgot the slope formula, it's y2 minus y1 over x2 minus x1. So when we're finding the slope, we're going to take the second y minus the first y, and then we're going to take the second x minus the first x. So that right there gives us 1 over 1, which of course is 1. So what we have is a slope of 1. And now what we need is a point. We actually have 2 points, so we get to choose which point we want. I'm going to choose the point 2, 5 because I think it's a little bit easier to work with, but technically 3, 6 works just as well. So when I plug it in, I'm going to go y minus 5 equals 1 is my slope, and then I have x minus 2. Now, just in case you forgot, our first value is the x, and we plug it in for the x sub 1. Our second value is the y, and so we plug it in for y sub 1. Now, what we're going to do is we're going to simplify it, so we distribute the 1 to each of the terms. So y minus 5 equals 1x minus 2, or you could just put x. Then what we're going to do is we're going to add the 5, and we have y is equal to x plus 3, or 1x plus 3. And that's our answer. Now, if ever you want to check to see if you're doing it right, what you could always do is use the other ordered pair, the 3, 6. If you plug a 3 in there, 3 plus 3 is 6, so we know we did it correctly. So that's one way of checking to see if you did it correctly or not. For the second one, we're going to do the same thing. We're going to find the slope. So we go m equals negative 3 minus negative 7 over 5 minus 3. So negative 3 minus a negative 7 gives us 4. 5 minus 2 is 2. So our slope is 2. Now what we're going to do is we're going to pick a point. I'm just going to pick the 5, negative 3. Once again, it doesn't matter what point you pick. You could pick either one. And so I have y plus 3 equals 2. And then x minus 5. So I have y plus 3 equals 2x minus 10. And then I'm going to subtract the 3. And I get y equals 2x minus 13. So example 2, what we're going to be doing is we're going to be looking at parallel lines. Now, what we have to remember is that parallel lines have the same slope. When we think about it in terms of lines, same slope means that the two lines are perfectly parallel. They never touch. So that means when we're writing equations, what we do is we look at our parallel equation, we identify what our slope is, and our equation has to have the same slope. So in this case, the slope is 2. So that means that the slope that our equation is going to have is also 2. So we're going to use the slope of 2, and we're going to use the 0.51, and we're going to write the equation. So we're going to go y minus 1 equals 2 because it's a parallel line, and then we have x minus 5. For the next, we're going to distribute the 2, so y minus 1 equals 2x minus 10. I add the 1, and I get y equals 2x minus 9. So looking at the next one, what I'm going to do is I'm going to get the y by itself. In order to figure out the slope, I need it in slope-intercept form. So I'm going to subtract the 3x, and I get y equals negative 3x plus 12. I have my parallel equation. I know that my slope is -3. Parallel slopes are exactly the same, so that means that the parallel slope is also -3. I'm going to use my slope, and I'm going to use my point, and I'm going to write my equation. Y minus 3 equals -3 x plus 2. I'm going to distribute the -3 to each of the terms. So I have y minus 3 equals -3x minus 6. And then I'm going to add the 3. And I get y equals -3x minus 3. And that right there is my answer. Now, the last thing that we're going to do is we're going to continue writing equations, but this time, instead of the lines being parallel, what they are perpendicular. So that means that perpendicular lines are negative reciprocal slopes. And if we think of it visually, if we have a slope or a line, our perpendicular slope is always going to make a 90 degree. And in geometry, you're going to talk more about that. But in terms for us, what we do is we look at the negative reciprocal, which means that we change the sign and flip the number. So we first identify the slope. In this equation, the slope is 1/2. So that means our perpendicular slope, and in geometry, they use the symbol for perpendicular like an upside down capital T. And so our perpendicular slope is going to be -2. Once again, we flip the sign. This is a positive, so we change it to a negative. And then our number, instead of 1/2, is 2. So that right there is our slope. Now we're going to write our equation. We have our slope, we have our point. So we're going to have y minus 2 equals, our slope is -2. And then we have x plus 4. I'm going to distribute the -2 to each of the terms. And so that gives us y minus 2 equals -2x minus 8. And then we're going to add the 2. And y equals -2x minus 6. And for our last one, first thing that we're going to do is we're going to find the slope. So in order to find the slope, we're first going to subtract the 3x. We need to get it in slope-intercept form. And we get -2y equals -3x plus 8. Then we're going to divide it by -2. And we get y equals 3/2 x minus 4. Now, when we're looking at this, what we notice is that our slope is 3/2. So what we need is our perpendicular slope. We change the sign and we flip the number. So it becomes a -2/3. So we're going to take our point, which is 6, 0. We're going to take our slope, which is -2/3. We're going to write our equation. Y minus 0 equals -2/3, and then x minus 6. We're going to distribute the -2/3 to each of the terms. Of course, 0 doesn't do anything, so we're just going to leave it as y, and that becomes -2/3 x. Negative and negative is a positive. The 3 and the 6 cancel, becomes a 2. So that would be a 4. And that right there would be our answer.